Okay, cool. I think we are recording.
I need to figure out, I have this linked up to the TV, so I need to figure out how exactly I'm supposed to share. Wait. Can you see that?
Yeah,
we can see it.
It says combating misogyny on social media platforms in all black. Okay.
Yes.
Yep, you're good.
Okay. So as I just said, this presentation is about combating misogyny on social media platforms. But then we're gonna branch out into just broadly toxicity later on. And as a content warning, there will be memes. So be warned. So let's first start off with the basic definitions. So what exactly is social media? Well, according to Tufts Communication Department, social media is the means of interactions among people in which they create, share, and or exchange information and ideas in virtual communities and networks. Wow. So now that we know what exactly social media is, we can go on to the next big idea, which is that social media is pretty big. In fact, exponential. Wow. So exponential, in fact, that according to this One World in Data graphic based on Statista and TNW, which records the number of people using social media platforms, you can see that Facebook has well over 2 billion users as of 2018. So this is sort of out of date. And YouTube has over 1.5 billion. And considering that there are only 7.9 billion people on this earth, we're playing with the big boys. So yeah, now that you know that social media is pretty big, it shouldn't come as a surprise that social media just can't seem to get rid of its toxicity. You know, you want the good vibes, but somehow it just keeps on chasing after toxicity. More on toxicity starting now. So what exactly is toxicity? You often see it thrown around like, oh, you're so toxic. Well, according to a Google Jigsaw issue entitled The Toxicity Issue, toxicity is specifically described as rude, disrespectful, or unreasonable language that is likely to make someone leave a discussion. So anyway, back to the person at hand, or the social media, for instance. Why exactly is social media so toxic? Well, social media itself can't be toxic because it's just a virtual platform, but rather it's the people on these platforms that are making such toxic behaviors. People can really be terrible in person and online, and this is a heavily documented effect called the online disinhibition effect, described in these papers in the corner, where some people self-disclose or act out more frequently or intensely than they would in person. And this is often due to a whole host of factors such as anonymity, invisibility, and lack of eye contact. So yeah, social media is toxic, but what exactly can we do to stop the toxicity? Well, when I thought of this question, my immediate thought was just destroy social media. But unfortunately for the companies involved, that's not very cash money in a very literal sense. So though, as an aside, imagine if we could destroy all of social media. Oh shoot, no, oh my God, wait, no, I need to go back. I'm gonna stop the share. This is technical difficulties. I, in fact, forgot to share my audio. Okay. Okay. Hopefully you can hear stuff.
Push button.
Okay, moving on. So I spent the majority of my time making this presentation, making that one clip. But now that we know that we can't, in fact, destroy social media, let's move on to the solution that many companies are actually pursuing nowadays, which is just to design ways to censor toxic speech using artificial intelligence. And the motivation behind this is that if we create computers and machines that can flag toxic speech like effectively, they'll be way more faster and way more efficient than any human could ever do it. And sneaky Will Smith meme in the corner looking up at design ways to censor toxic speech, parentheses AI, is also a clever segue into my next slide. Yes, Will Smith, that is hot. But this topic is so hot that Wired actually made an article about it 9 days ago about these papers in particular. So in this presentation, I will be talking about, broadly speaking, what exactly is the problem Wired is trying to discuss in this article, why exactly this problem is so difficult to address, and how exactly Wired proposes to solve this. And then I will branch off into other ways to solve this issue, broadly speaking. So first off, what exactly is the problem Wired is proposing? Well, from the title of this presentation, this is about misogyny. Misogyny is such a big issue on social media platforms that, according to a PLAN International study conducted in October 2020 on over 14,000, which included over 14,000 young women and girls responses in over 22 countries, over 58% have reported being harassed or abused online. The highest incident of these attacks occur at a 39% reporting percentage happening on Facebook, followed by 23% on Instagram, 14% on WhatsApp, 10% on Snapchat, 9% on Twitter, and 6% on TikTok. About 1 in 5 or 19% stop or significantly reduce use of the platform on which it happened after said harassment, and about 1 in 10 or 12% change the way they express themselves after the harassment occurs. Okay, so now that we know why this now that we know why this issue is so difficult to address, oh my god. Okay.
Is that your background?
Yeah.
Sorry,
I think
I lost my train of thought. Okay, so now that we know why misogyny, okay, now that we know why, okay. Now that we know why misogyny is so prevalent in social media in general, Wired then goes into why exactly this issue is so difficult to address. So companies that currently rely on AI to flag toxic speech. Okay, so basically companies, or these models that companies currently are relying on to flag toxic speech are often based on very biased data sets. So as I sneakily put in these articles in the corner, one such example of dataset biases found was in the first paper, well, actually 2 papers, the first of which found that leading AI models for processing hate speech were 1.5 times more likely to flag tweets as offensive or hateful when they were written by African Americans, and 2.2 times more likely to flag tweets written in AAVE or African American Vernacular English. The second paper of which found widespread evidence of racial bias against Black speech in 5 widely used academic data sets for studying hate speech that totaled around 155,800 Twitter posts. The second of which is that in general, a lot of AI models just use a bad word list in which they just have this list of bad words that they deem as always toxic. So this could lead to potential problems with, just mention of minorities ending up with a higher toxicity flagging than just not mentioning them at all, which is discussed at length in the third paper listed in that group of papers. Wired also mentions that different language can result in different manifestations of misogyny. So it's difficult to find one uniform way of determining what exactly misogyny is if it varies between languages. So in this quote by Elisabetta
Wait,
Fersini.
quick question. For AI models that are using like blacklists of words, are those like trained models? Like, are those like deep models that end up basically centering on only a few words as if they were using a blacklist? Or are you talking about models that are like not really models, but really more just like if else to control flow statements that explicitly block certain words?
So it depends, because sometimes models are trained at length that they end up only focusing on a set of bad words. And then other times,
fitting basically to the yeah.
Other times companies don't want to use, they just use a blacklist that they create themselves. So it happens in both ways. So in this quote by Elisabetta Fersini, who is an assistant professor at the University of Milan Bicocca in Italy, she noted that online posts in Spanish have a higher proportion of sexist content related to dominance, while Italian social media users lean towards stereotypes and objectification, while English speakers seek to discredit women more often than their Italian or Spanish counterparts. So in addition to just the types of insults that we experience in different languages, you should also take into consideration the fact that languages can be gendered or non-gendered. So for example, Romance languages can be gendered, while languages like English or Danish are non-gendered. So now we'll segue into how exactly Wired proposes that we solve this using these studies. So in this first study done at the University of Copenhagen by researchers Feline Zeinert, Nana Inye, and Leon Dzerzhinsky, they invited Nina Norgard, who is a PhD candidate at the University of Copenhagen, as a mediator for 7 discussants to identify different types of misogyny on 30,000 Danish Facebook, Reddit, and Twitter posts. So they basically met up over the course of, I think, half a year, and just sat down and discussed whether is this misogynistic or not. One interesting thing that Wired notes is that the highest form of sexism found in these Danish posts was actually neo-sexism, which denies that misogyny exists and that we've already achieved equality. And I just put this in because it's sort of interesting, because it's already a documented phenomenon found in Scandinavian nations like Denmark and Sweden. So it checks out that they were found in Danish posts. How exactly is this different from like how we're labeling data normally? Well, there's no mechanical Turk. They said that they deliberately chose people of different ages and nationalities with varied political views to reduce the chance of bias from a single worldview. They notably included a software designer, a climate activist, an actress, and a healthcare worker among those 7 discussants. And researchers say that AI fine-tuned with the data that they created can recognize misogyny on popular social media platforms 85% of the time. And a year earlier, a year before this paper was published, a state-of-the-art misogyny detection algorithm was accurate about 75% of the time. So it was a 10% accuracy increase. In the second study that Wired also mentions, researchers from the Alan Turing Institute and UK-based universities also invited annotators and a mediator to review more than 6,500 Reddit posts for misogyny. I think it was sort of interesting that the researchers noted that they focused on Reddit specifically because it's increasingly home, quote unquote, increasingly home to numerous misogynistic communities. So the posts were read in chronological order for context, which is different from just flagging one part of speech without that context, because sometimes that can lend more answers as to whether it's misogynistic or not. And they purportedly claim that an AI model fine-tuned to this data has a 92% accuracy. So as I mentioned before, with all these different issues with like cultural and language differences in misogyny. It's Wired notes that it's often really hard to establish guidelines for identifying misogyny. One guideline in particular by Pulkit Parikh, who is a doctoral student at the International Institute of Information Technology in Hyderabad, India, created this Everyday Sexism Project, which has 23 categories, ranging from hypersexualization to hostile working environments to sexual harassment or mansplaining. But so even though these guidelines are difficult to come up with, one thing that both of these papers agreed on is that in order to better create guidelines, you just need more time to discuss disagreements over labels. Yeah, because conversation just leads to clarity, I guess. Wired also interviewed Mary Gray, who is an anthropologist and senior principal researcher at Microsoft, who noted that what bothers me about Study One approach is that it assumes that there could ever be a set of annotators that could look over a corpus and produce a classifier that applies to everybody in the world, which is definitely true. How can you do that for an entire group? So the solutions Wired proposed honestly did not leave me that hyped, especially since this seems like the most obvious approach. Like, if you have bad models trained on bad data, create better data and train better models off of that. But that just seems like a very straightforward and also time-intensive approach. So this is where I go off the rails and look at other ways to combat this that don't include just creating new, more accurate data. So then I went to Google Scholar and I found this particular paper called Challenges in Automated Debiasing for Toxic Language Detection by Zhou et al. And they basically describe ways to try to detoxify currently toxic models using methods that aren't just creating new data sets. So as I mentioned before, current toxic language detection systems often rely on the presence or absence of certain words like swear words or identity mentions to make their predictions. One thing I forgot to mention earlier was that these things have lasting effects even today, where, for example, on TikTok, they censor like death and suicide. So TikTok users have found a loophole around that by using the word unalive rather than like kill or suicide in order to escape these censoring measurements. And I thought that was interesting, but I just forgot to mention it earlier. There's definitely more nuance than just having a bad word list. There is lexical bias and there's dialectal bias. So in response to the nuance in language, these researchers basically created a data set of toxicity triggers, which they affectionately named ToxTrig, which I thought was sort of funny. These in particular are these three categories, the first of which is NOI, which is descriptive mentions of minoritized demographic or social identities that aren't meant to be offensive. So you could say like, I am an Asian woman, and Asian and women have a higher toxicity rating, but in this context, I'm just using them as like identity words. So they shouldn't be toxic. OI are mentions of minoritized identities that could denote profanity or hate depending on context. So these are actually like racial slurs or something. And ONI is profanity not associated with any social groups. So pardon my French, fuck or shit, those things, they're profanity, but they aren't tied to any specific race, if that makes sense. After they split up this data set, they also proposed different ways of debiasing these models, the first of which is additional training objectives. So training the model to learn how to ignore biased data in these data sets, they used the learn mix-in method, which trains a bias only and a full model. So this sort of didn't make sense at first. So I went to the paper that they referenced and pulled this infographic that they had. So in this particular picture, it's an example of applying this learn mix-in method to a visual question answering task. So they assume in this picture that predicting green is almost always correct on the training data. So to prevent a model from learning this bias, you train a bias only model, which is the middle infographic, or like beneath the middle infograph, that only uses this question as input, and then train a robust model in an ensemble with the bias only model. So since the bias only model is trained to always return green, and has in effect already captured this target pattern, the robust model will have no incentive to learn it, and thus does better in general with test data where the pattern is not reliable. So back to that. Yeah, so like you train a bias only model and a full model, and then in the end you discard the bias only model. So then you'll have bias free model maybe. The second method is, so the first method was, can we train the model to ignore toxic data? The second method is, can we just filter out toxic data from our data set and then train our model on that? So they use two different methods, one of which is AF-Lite, which is, I wasn't too sure about it, but it's, the paper describes it as simple linear classifiers that are trained and tested on different partitions of the data, and predictable instances are then discarded. So stuff that's outrageously toxic, I think, are discarded. So then the data set will be less toxic, I guess. And data maps, which defines easy, hard, and ambiguous regions of a data set, and then trains specifically on those regions. So only on easy, only on hard, or only on ambiguous. And it's sort of interesting. So previous research with data maps found that training on hard and ambiguous parts of the data set are beneficial for the model's accuracy, but training on easy parts of the data set result in a decreased accuracy. So that's an interesting thing to take note of. The final method that the researchers in this paper proposed is purely proof of concept, as they like to mention, which is relabeling previously toxic labels to be non-toxic. They stress it's proof of concept because GPT-3 has likely not been exposed to African-American English varieties during training, and pre-trained language models are known to generate toxic language at non-trivial rates. But in essence, they're basically creating a translator using GPT-3 to translate African-American English into white-aligned English. And they then run like a toxicity classifier on both the African-American English and the white American English translation. And if they flag the African-American counterpart as toxic, but the white aligned counterpart as non-toxic, then they relabel the African-American tweet to be non-toxic. And these are the results. So basically, it's a really big table, but I think if I can, is there a, can you see my mouse?
Yeah.
Okay.
Yep.
So vanilla and random are the two baselines they went off of. They had to create two baselines in essence because the filtering methods only train on 33% of the data. So random uses a baseline Roberta large classifier on either the full data set, which is vanilla, or a random part of the data set, which is random. So basically these numbers represent the mean and standard deviation in a subscript of the accuracy, F scores, and the false positive rates on either the whole testing data set or the three different groups of words that we identified earlier as either being non-offensive minority mentions, offensive minority mentions, or like not related to minorities at all, or identities at all. So the takeaway from this graph is basically that while data filtering approaches achieve a higher overall performance, debiased training approaches perform better on lexical bias reduction in aggregate, which basically means that if you can see here, like the bolded, the bolded number is basically the highest accuracy rating in each of these columns, and they all end up in the filtering methods, but model debiasing works better in general. And
Is FPR false positive rate?
Yes, FPR, F1 are F scores, FPR is false positive rate.
Am I reading that OI column correctly in that it's saying there's an 83% false positive rate on the right?
Yep. So
that is really high.
What? Terrible. We're saying that, oh, it's sort of better, it's sort of not, but yeah, they don't really work that well.
Okay.
And then looking at this other,
like even like a 6% false positive rate, like could you imagine if like 6 out of every 100 messages that you sent or something were like flagged for abuse?
It's pretty terrible.
That's really funny. Okay.
Yeah. The second image also displays the F score for lexical biases on the full data set and 33% of the full data set with all these different methods. The takeaway from this is that all models perform poorly at identifying toxic text not containing overtly lexical cues of toxicity. So they trained these models on sentences that didn't have any overtly toxic words in it. So the example they included, which was sort of funny, was cheese is made by French people who smell. Like each one of those words isn't inherently offensive, but the sentence as a whole is offensive. So they're all terrible. That's the takeaway here. It's like the F score is 7.5. And somehow the random set performed way better than all the other filtering methods that they had, which is sort of funny. The next thing is that they also tested on the white align versus African American English correlation, and basically found that both debiasing methods improve performance over the baselines, with data maps hard proving the most effective at debiasing. And the relabeling results, which was the third method that I mentioned before, results in a model which, despite following a noisy process, yields even larger improvements for dialectical debiasing. So looking at strictly this first half of this chart, W toxicity indicates the percentage of white users' tweets being flagged as toxic. AA toxicity indicates the number of African American users' tweets being flagged as toxic. The delta refers to the difference between African American toxic and white toxic. And AA/W refers to the ratio between African American toxic and white toxic. So you can see that the bottommost third proposed method has the lowest ratio, but it's still honestly sort of bad. So yeah, that's sort of interesting to take note of. And if we go into the second part of this chart, which is just here, the takeaway is that methods generally fall in debiasing on this test, except the labeling or relabeling. Only the relabeling approach shows some like chance of promise, and then everything else sort of sucks. So the RAAE is the toxicity to African American English correlation, while this is the false positive rate and this is the F1 score. So they're all sort of terrible. Yep. So I'd like to close with this quote that the paper ends with, which is that our findings suggest that instead of solely relying on development of automatic debiasing for existing imperfect data sets, future work should focus primarily on the quality of the underlying data for hate speech detection, such as accounting for speaker identity and dialect. So, well, I guess the Wired was right. So, the end.
Yay.
Find me in the office until August 15th. Great. Cool. Thanks for the presentation. This was really good. I don't know. I have a lot of thoughts on this actually, which is sort of funny because I worked in spam and abuse at Google for like a year and a half. I think I have like two thoughts. One is like I don't know if you've been on YouTube comments recently. Not that like anybody should really spend a lot of time on YouTube comments, but like, you know, it used to be that YouTube comments was like the scum of the earth. Like it was like the worst place you could ever find anything reasonable. Now it's like actually kind of good. Good is like a relative sense. And it's like, it's not going to like, you know, you're not going to find like absolutely horrible things. The reason is because it turns out that like the long tail of racist and misogynist comments are actually just so explicitly racist and misogynistic that like even having like a really, really, really dumb filter actually manages to clean out like 90% of the crap that you'll see. No, I'm serious. Like people are not like subtle, you know, people like make spam accounts and then just be like, you know, F word, F word, F word, F word. And that's it. You know, like that's the level of, yeah, that's like the level of quality. So like, certainly there's like, I think there's a lot of difficulty if somebody's trying to mask their intention, but it turns out that the vast majority of people on the internet are like trying their hardest not to mask their intention when they're trying to be racist or sexist or whatever. So, yeah, also definitely thought it was funny that like even the best models were like 6%
Yeah,
false positive.
that was honestly really sad.
Has there been much work on, we were talking to Sarah about this the other day, but and I apologize if this was in the first 10 minutes of the presentation. Sorry for being late.
Wait, Jake, I can't really hear you. Can you speak up a bit?
Yeah, Sarah and I were talking about this a little bit earlier, but I wonder if like focusing more on this identity of the speaker and being able to basically like can you get higher quality results by clustering people who have a high propensity to use hate speech, even though the like many of the statements themselves are hard to flag, or you know there's like a high false positive rate, that if you like focus the filtering on the user identity rather than on the individual comments, that you might have like a higher success rate for basically like preventing hate speech from occurring on the platforms. Does that make sense what I'm saying?
Yeah, so actually that's like, I can't say this for certain on whether or not they do this on social media accounts at Google. I suspect they probably do, but they do definitely do this for advertising accounts. So like I worked on graph mining, and one of the things that we do on graph mining, or I should say did on graph mining, is like we cluster accounts based on a lot of different properties. And if it turns out that like one of those accounts in that cluster ends up being like really spammy, we take down the entire cluster. And that actually works really, really well. I mean, there is ostensibly a way to appeal, you know, but like very, very few actors, like I guess like user accounts end up going through the appeal process in large part because they are actually spam.
The reason I think this is interesting is, especially for people like us, where, you know, beyond just like a resource consideration, you know, because obviously it's like a monumental task to like to take on the responsibility of you know, ensuring high quality interactions on that work. That like, you know, in some ways it's like it comes down to the people that you have interacting with you, and that we might there could be a way for us to like actually have like really high quality level of discourse by just being really selective about user behavior and saying like, you know, focusing your attention on like particular account behavior, we're just like going to be very quick to kick people off. Like rather than censor individual messages or individual interactions, just be quick to say like, hey, we don't think that this platform is for you. Basically.
Yeah. Can you Sarah, can you go back to the Mixin slide?
Okay. I need to figure I need to figure out how to. Okay. No, it's not this one.
Amor, are you recording everything?
Yeah.
What? The image or just like mixing?
Yeah, this is fine. Thanks. No, go back.
Okay.
Yeah, that's good. So I find this really interesting because I feel like this is actually, so you can imagine like a perfectly debiased model, right? A model that like when you ask it what color is the grass doesn't produce any bias. But I also feel like that actually like, I don't know. I find this really interesting. Like what you're doing here is breaking the deep learning model, right? Like you're explicitly trying to prevent the deep learning model from doing what it does, which is like learn correlations and things. So like this is like explicit in the like obviously I think when we're talking about language and like how language can be used for statistical modeling, we can identify places where like that statistical modeling is fundamentally flawed. As an example, like if it turns out that like certain words end up being used much more commonly in hate speech, then the model will end up statistically tagging that to be more likely like hate speech to begin with. But like, I think the what color is grass question really exposes that problem of like, well, there's some benefit in having a model assume that the answer is green. And you can extend this back to like, like even the hate speech problem, like just on face, if you saw a string that was filled with curse words, would you assume that it was hate speech? Like in a vacuum, it probably makes sense to actually say, yes, that is hate speech, and you would be right most of the time. And so purposely training a model to avoid that kind of bias actually seems like it might be harmful to me, because then you're just making like the platform worse because you're not able to get those low-hanging fruits. Even if it results in picking up some like additional even if it results in picking up some additional things that are not necessarily harmful. Does that make sense?
Yeah, it does. I mean, yeah, I think it is very human to just have preconceived notions about everything, because that's clearly how we perceive the world. Maybe if there's some sort of like tiered model of some sort, which like still somehow included the bias only model, but I think, yeah, I don't know.
I mean, having an ensemble is really good generally. Like I find this picture interesting because like the actual thing that ends up being used at inference isn't the bias only model, right? Like it explicitly does not use the bias only model for the predictions at eval time. It only uses the robust model, quote unquote. But I do find this interesting because I'm curious then like how the gradients end up getting passed through so that it ignores the bias only model. Do you know anything about that?
No, unfortunately, I did not read too much into the learn mixin method.
Okay.
But
yeah, because it looks like it's passing gradients back to the robust model only and not to the bias only model, which also is weird. Like I'm curious how the bias model is then like generated. But yeah, it looks like the gradients are passed only to the robust model. So I'm kind of curious how the ensemble actually like learns to discount the bias of the bias only model, so to speak. I can think of like a couple of ways that involve like playing with the gradients, but none of them feel very satisfying. So I'm curious how they did it. I might look at the paper later.
yeah.
Cool.
I had a question, just generally, like, so wait, so up until like relatively recently, YouTube comments didn't even have like any filter, like you could post anything.
Are you asking me?
Yeah, like don't they like censor the hell out of like if there's like a clip of like music, one like song in the video, they like shut down the whole thing. But like they had
okay. I mean, YouTube gets a lot of flack for good reason because like their customer support is really, really bad, and like yeah, like it's really easy to get your like I don't say really easy. It's like it's relatively easy to get like strikes because of DMCA and stuff like this. That being said, YouTube gets something like hundreds of thousands of hours of video content uploaded every day. Like the problem that they are facing is like almost fundamentally intractable. And so you end up seeing like a few high profile cases where somebody's like, I had white noise in my video and that got flagged by DMCA. And like, yeah, like that sucks. And I understand why that could feel like really Kafkaesque. But on the whole, I'm personally like somewhat sympathetic to the idea of like, well, if you want to have some level of like, law enforcement, whether it be like spam or like in this case, copyright, which I don't really like copyright. That's like kind of like a painful necessity in the current world. Some people I think would argue that like, well, you shouldn't have this at all, but then, you don't have YouTube. That being said, no, I think there was always filters on YouTube comments, but for a while, those filters were done either manually, which was intractable because there's just so many comments that are posted, or they would be done using like a blacklist model, which also is like, for reasons that Sarah kind of mentioned already, really intractable. I also posted a link to in the learnings channel about the Scunthorpe problem, which is really funny, which is basically like an example of how blacklists like kind of don't work. And that specific example was one where in the late 90s, nobody from the town of Scunthorpe, UK was able to create an AOL account because AOL was picking up on the fact that Scunthorpe has the word cunt inside of it, which is really funny because obviously like these people needed to be able to access the internet and they weren't able to do that. And so like blacklists fail for that reason. And so like they're like very easy to circumvent for people who are trying to get around them, but very, very like easy to fail on like obviously wrong cases. Now I think they use like AI models, which is why they're so much better.
Got it.
Specifically transformers, actually.
Interesting. Cool.
All right. Thanks so much, Sarah. This was a great presentation. And I think next week we don't have a journal club. Depending on how things go, Sarah and Robin, maybe you guys want to do a presentation on the work you guys did. That frown suggests maybe she doesn't. We'll decide whether or not. I mean, maybe, I don't know. Like you guys did a lot of really good work for your internship, so maybe you guys should present on that. But kind of up to you. If you want to spend that last week working on other stuff, that's totally okay. Otherwise, the week after that, we'll be going back into our normal rotation. I'll have to look at the journal club schedule to see who's up. Joel, I'll be adding you to the schedule rotation as well. So just keep an eye out for that. Thanks, guys. This was a lot of fun.
Bye.
Thanks. Bye.